Okay, let's solve some angles now. So we're asked to solve for angle x. Relative to angle x, let's label our triangle. 15 would be our opposite side, and 20 is our hypotenuse. So we're looking for a ratio involving O and H, and that would be sine. So we know sine of any angle theta is opposite over hypotenuse. So sine of our angle x is going to be 15 over 20. So in decimal form, that is, I think that's 0.75, right? Yes, 0.75. And so now, if you're like me, you can think of this as taking the sine inverse of both sides, because we want to cancel that sine on the left, and sine times sine inverse cancels each other out. And so we're left with angle x is sine inverse of 0.75. And so I do sine inverse of my previous answer on my calculator. We've been asked to round to the nearest degree, so that would be 49 degrees when I round. Okay, next one. So let's label. So we're dealing with an adjacent side here and a hypotenuse. So that means we're talking about the cosine ratio. So cosine of any angle theta is adjacent over hypotenuse. So cosine of our angle x is 17.3 over 30. Let's convert that to a decimal. And again, you can leave this decimal answer just stored in your calculator, or write down quite a few digits for it. So it's 0.5766. And so then if we're trying to solve for angle x, we can take the cosine inverse of both sides. So we're going to take the cosine inverse of that decimal answer. And so on my calculator, I do cosine inverse of the previous answer, which gives me, to the nearest degree, 55 degrees. Okay, moving on. So relative to this angle x, we are dealing with an adjacent and hypotenuse. So we want a ratio involving a and h, which is cosine. So cosine of any angle theta is adjacent over hypotenuse. So cosine of our angle x is 3.6 over 5.1. Let's get the decimal answer of that. So 3.6 divided by 5.1 gives me about 0.7059. And so to find angle x then, I'm going to take the cosine inverse of both sides. So I'm going to take the cosine inverse of that decimal answer. And once again, I just leave the whole thing stored on my calculator to make it very exact. And so I do cosine inverse of my previous answer, and I get 45 degrees to the nearest degree. Okay, next one. So relative to angle x, we've got an opposite and a hypotenuse. So we're going to want to use the sine ratio. So sine of any angle theta is opposite over hypotenuse. So sine of our angle x is 305 over 462. Let's convert that to a decimal. So about 0.6602. And so to solve for the angle then, I'm going to take the sine inverse of that ratio. And when I do that, I get 41 degrees. All right, next one. We've got a hypotenuse here and an adjacent side, so we're going to use cosine. We know cosine of any angle theta is adjacent over hypotenuse. So cosine of our angle x is going to be 4.85 over 6.02. And in decimal form, that gives us about 0.8056. So now to solve for angle x, we're going to take the cos inverse of both sides. So we take the cos inverse of that ratio. And we get 36 degrees rounded to the nearest degree. Okay, and last one. So we know our hypotenuse and we know our adjacent. So we're once again using the cosine ratio then. We know cosine of any angle theta is adjacent over hypotenuse. So cosine of our angle x. You thought it was going to be sine, didn't you? Because the last one was cosine. Look how tricky we are. Okay, so cosine is 83.4. Oops, 83.4 over 95.3. And the decimal equivalent of that ratio is out to 4 decimals, 0.8751. So to solve for angle x then, I'm going to take the cosine inverse of that ratio. And that gives me, out to the nearest degree, 29 degrees.